as our polynomials start to get a bit more involved as far as the variables go, our greatest common factor is still going to be the largest number that divides into our coefficients. In this case, 3. It goes into all 3 of them. And now where we would think greatest common factor, we want to think the greatest exponent, it is the largest number that goes into the coefficients for our GCF, but as far as the exponents go, it's actually going to be the smallest of the exponent, which was even the case up on these problems where we had no exponent, meaning why, with our constant, it was only the integer. But when we look at the smallest exponent is going to be the most x's we can pull out. Remember, x to the fourth means I have 4 x's. X cubed means I have 3 of them. X squared means that I have 2 of them. X squared is going to be the most that I'm going to be able to pull out of all of them. So when I look for a GCF, what I want to do is look for the largest number that divides your coefficients and look for the smallest exponent is going to be the most that we can pull out. Well, when we pull it out, when we look at how to factor and how to divide that GCF out of all of the terms in the polynomial, just like the opposite of distributing, where here we would multiply and add any exponents, here we're going to divide the coefficients, and here we're going to subtract the exponents. So when we divide our coefficients here, I get 2x, subtract my exponents, 2, coincidental that they're both the same. Make sure you're careful with the signs, or I have a negative and a positive. It's going to be a negative. 3 divided by 3 is 1, but remember to be simplified, we don't put the 1x squared. Where I have x cubed divided by x squared, I'm going to subtract the exponents, leaving me with just a single x. Divide my coefficients, 7. X squared is going to cancel once again. To check myself, distribute this back out. 3x squared times 2x squared, multiply my coefficient, 6, add my exponents, 4. 3x squared times negative x, positive times negative is a negative, 3x cubed. 3x squared times 7, 21x squared. Here's the factored form. And stay in the habit of distributing. Just check yourself. You can know whether it's right or wrong before you even submit the answer. Now the next problem, what I want to show and what I really want to illustrate with this example is that to some degree there will be a guess and check to make sure it is the largest number that divides your coefficients. When we look at a problem like this, we can see clearly, well, 3 is a small number that goes into each of these, but it's not the greatest. 9 goes into them. All right, well, 9 is bigger than 3, so at least that's a step in the right direction. But what about 12? 12 goes into both, but 12 doesn't go into the 45. We can check 18 goes into both of the first 2 coefficients, but not the 45. There is a certain amount of guess and check to make sure that it is the largest, but to make sure that it actually goes into all 3. And there is a certain learning curve as you get used to some of those. In this case, 9 does happen to be the largest number that evenly divides into all of those coefficients. We look for the smallest exponent. It's just going to be that single x this time. So when we factor it out, divide the coefficients, subtract the exponents. 8x cubed, 72 divided by 9 is 8. 4 minus that 1x is x to the third power. Careful with your signs. 36 divided by 9 is 4. Left with x squared. And factoring out that x, 45 divided by 9, 5. And again, check yourself by distributing. Remember, this is the undistributive property. This is factoring the GCF.